Ansu, and I'll be doing grade 11 mathematical literacy. And today's topic is data handling. Data handling is actually in 2 sections, so I'm just going to start now with section 1. What is data? Like, if you have to give a definition of data, what I mean with data handling, it's actually when I say you have a question and you want to know what the possible answers to your question. So let's just quickly look at very important terminology. Data is raw information that has been collected without any organization or analyzing the data. Data handling refers to the process of collecting, organizing, summarizing, and representing and analyzing the information. Statistics is the branch of mathematics that focuses on collecting, organizing, representing, analyzing, and interpreting data. So the statistical process, as you can see here, is what you do when you want to handle your data. So firstly, you're going to develop and pose a question. After that, you're going to analyze your question or your data. So you can see, is this question relevant to what I actually want to find out? So for instance, if I want to find out if the grade 11 mathematical learners understand this video, that's my question. My question is, do grade 11 mathematicals understand the question? Then I'm going to go and I'm going to look at the question. Will it give me my answer that I'm looking for? Don't I actually want to know how they're doing overall? Then it can't just be mathematical literacy. So that's what I mean with analyze your question. After that, you're going to collect your data. So let's say I use my question. Does grade 11 mathematical literacy, do they all pass? That's my question. So now I'm going to collect my data. So I'm going to take, let's say, quite a few schools, and I'm going to take all their grade 11 learners, and I'm going to look at the marks. That's my collecting of the data. So I collected all the relevant data for my question. Then I analyze my data. Is all the data that I collected just about mathematical literacy? Yes. Then I can continue. The next part is classifying and organizing the data. So now I have my data. Now I have to order it or write it in such a format that I actually understand it. So I'm going to organize it and sort it and classify it and write it in tables so I understand my data that I collected. After that, I'm going to summarize my data. I'm going to do a few mathematical examples to see if my data is giving me the relevant information that I need. And lastly, I'm going to put it in a graph so I can actually understand it and see that the graph is working correctly. The graph is looking correctly. So the first step is developing a question. So in this statistical process is to develop and pose a question. Each question developed or posed should have a main aim or reason for investigation, followed by sub-questions, which provide additional information into the investigation. In other words, my main aim is to see if grade 11 mathematical learners are passing. But my sub-question is, I want to know if they will be able to pass matric. Be aware for being biased or being rude or being dishonest on your questionnaires. The next step is collecting data. There's 3 main methods of collecting data. It's observation, interviews, and surveys. So what is observation? Observation is where you actually go and you sit down and you look at the people in front of you. Observation is more for like animals. If you can't actually go and ask a squirrel a question, so observation will be where you actually sit and you look at squirrels. If you have a question about squirrels and you observe them, that's mainly where you're going to use an observation. Interviews is you sit the person that you are interviewing or that you want to know the question about, you sit them across from you and you ask them all the questions. This is a very timely matter, but it's actually, you get more accurate answers. And then lastly is a survey. It's like a questionnaire. Most of us have done a questionnaire somewhere in our life. It's where they ask you questions and you just have to answer them to get you to your relevant data. So what's your advantages and disadvantages of the different collection methods? Let's look at the first one, observation. Observation, the advantage is easy to record the info. Participants don't fill in the forms. Disadvantage is very time consuming, and the accuracy is based on the observer. So let's just take another example. Say, for instance, I'm going to look at, I want to know if a mechanic actually works. I won't be able to tell you anything, so the accuracy will be zero, because if I look at a car, I just see a red car. I don't actually see a name brand, or I don't know how the machine works. So if I have to observe someone in their field and I don't know anything about that field, I will be lost. And then the observer will be, I won't be for any use as an observer. The next one is an interview. Advantages: it allows for discussion between the researcher and the interviewee. The researcher is present to clarify wording. That means, in other words, the question is a bit vague and they don't completely understand the question. Then you are there to help them and make them understand what you are actually asking. The researcher can ask the interviewee to clarify responses. This means, like, if they give you a vague answer of maybe, then you can ask them why maybe. Isn't it a definite yes or a definite no? So you can ask them and you can clarify the responses. And the interviews tend to be more honest. If you are talking to them straight face to face, they tend to talk more freely. Disadvantages: is very time consuming, especially you have to have an appointment with each and every person there. So it can take very much a lot of time from you and take a lot of time from them. It can be expensive because you need to pay for a lot of things. Sometimes they even pay you to have an interview with them. So it can be expensive. Difficult to arrange because we live in a very busy schedule. We all have a very busy schedule, so sometimes it can be difficult to get an opening for both sides, and difficult to target a large audience or a wide geographic area because you need to have an interview with each and every person. So the larger the group, the more difficult it's going to be for you. And then last method is the survey using a questionnaire. It can be completed by many people simultaneously. It can be distributed in different ways, and this means it can be online distribution. It can be a piece of paper that you give. It can be mailed. It can be telephonically. You can ask the questions in very different manners. It can be fast and easy to complete. Can be completed at a convenient time. So if you want to do it at 2 in the morning, you're more than welcome. You won't, it will be easier for you to pick your time when you want to complete the questionnaire. It can be applied to many different areas of research because the questions is based on your research, and can target a large audience or wide geographic area because um, it's not just for you that you need to see the people. So it can be someone sitting in Cape Town while you are doing your research in Mpumalanga. It doesn't matter. The geographical area doesn't matter. Disadvantages: a researcher is not always there, always present to clarify wording. In other words, you can't act if they not sure about something, you can't help them. People cannot explain their responses. So if they give a vague response, you need to work with that. People may not complete the questionnaire. They, especially if the questionnaire is too long, they might feel, oh, they don't want to finish it or they don't want to complete it because it takes too much of their time. The questions can be vague. If they have to answer open question, they can answer it vaguely and you can't actually get the answer, and people can be dishonest. One I want to add here of a disadvantage for questionnaire is sometimes people don't see the seriousness of the questionnaire and they might make a joke of it. Okay, so let's just quickly look at the questionnaire because that's the main or the most obvious choice. A questionnaire is a tool used to conduct a survey. Questionnaires can be completed online, in person, telephonically, or by mail. I already told you guys this, but this is just again that I stated for you guys. Features of a good questionnaire include. Now here you have to please concentrate because these are your features that is going to give you the most accurate data. So the first one is aims of investigation are clearly stated. The question matches the aims of the investigation. You can't ask something about mathematical literacy when your question is about mechanics and working in a car. It must be relevant to your data or to your question. Instructions are provided on how to correctly answer the question. So you need to tell them, I want you to tick the box. You can't just leave it open and for them to decide, because then usually they don't complete the form as you would like. The questionnaire is short and simple. As I said earlier, if it's too long and complicated, people tend to only do half of it and then decide they're not going to complete it or it's wasting their time. The language is clear and matches to the level of participant. You can't use high English for a grade 4 learner. You need to, your language should be in such a format that everybody understands it. The question of avoid bias, and here's just a quick example. Don't you think that McDonald's burgers are better than Burger King's? Obviously, this guy likes McDonald's burgers. And obviously, he kind of want you to also like McDonald's burger. So it's a bias question. There are more closed-end questions as opposed to open-end questions. In other words, yes, no, a specific time, a specific amount, instead of what do you think or what do you feel? Because if you do what do you think or what do you feel, you're gonna get a lot of information, but nothing that you can actually use in your data set. So your information, if you're going to have an open-end question, you're not actually going to slimline it, if I can say it like that, slimline the data so you can use it. It will be too much information on too many levels and you won't get the answer you want. Questions are stated positively. Do you like opposed to negative stated questions? Don't you think? The reason for this is you want to keep the reader interested in your questionnaire. They want to feel positive. They want to feel good about themselves. If they feel good and if they feel positive, they will continue. If they feel negative, they might not want to continue with the questionnaire. Personal information is not required unless absolutely necessary. Okay, this is, I feel this is right. You're not allowed, or you shouldn't ask for personal information, but sometimes it helps to have personal information, because if you have personal information, people tend to be honest. They tend to give you straightforward answers, whereas you don't have personal information, they might give you weird answers or not the correct, honest answer. But if the question that you're posing is sensitive to the reader, then obviously you can't have personal information, because they won't want to disclose their sensitive information. Sufficient space to allow for response on the questionnaire. This is just if you have a tick box, make sure it's a nice big one. It can't be a teeny weeny one and nobody can, or they're going to mark over their own work. This is just an example of a questionnaire. So the aim of this questionnaire, there it says the question for you, what they want to find out, the investigation that they're busy with. It's about the transport for and challenges for workers. Here's your instructions. Please answer the following questionnaire by ticking the relevant box or by providing the necessary information. So they tell you exactly what they want from you. So, do you own any of the following modes of transport: car, bicycle, motorbike, or none? So that it's very clear end question. Do you own it? Yes or no? There's what do you own? There's not a lot of options. So this guy or this questionnaire is going to give you exact answers. You either have a car or you don't. You either travel with your private owned, a company owned, or government vehicle, you don't. This is a good example of closed end questions in the questionnaire that's short and sweet, and you will actually be able to use this data in a relevant matter. Okay, here's just another two definitions that's very important that you need to know. A population. A population in statistic refers to the entire group of interest. So let's say, for instance, I take again my grade 11 mathematics literacy. The population will be the entire grade 11 mathematics literacy in South Africa, where a sample is a representative part or slice subset of the population. So in other words, my sample will be, let's say there's 100 mathematics literacy students, I will use 50 of the students. And that 50 students should give me a fair representation of the whole population. A good sample, but guys, remember, a good sample, here it is, the characteristics of a good sample, and it must be there, otherwise your data will be inaccurate. So the first one is a representative of the population in terms of male, female, age distribution, race, culture, language. So I can't just take 50 females and say, okay, shop, now I'm going to have a proper set of data. I need to distribute it between male and female, ages, race, culture, language, so I have a clear view of my data set. Next one is randomly chosen, where each person has an equal opportunity of selection, or one selection is independent of another. In other words, you're going to choose your 50 people based on this first sentence, but you're going to choose it randomly. You're not just going to take your top performers or your low performers. You're going to take an average. Overall, anyone can go. So that will give you the base representation of your data. It must be large enough. If you have 100 people, you can't just take 5 people and expect that 5 to represent the whole number. You will miss out on a lot of information. Free from bias. Yeah, I think that's self-explanatory. Reliability of the data is largely dependent on fulfilling all of the characteristics of a good sample as listed above. So if you don't have a good sample, your data might lack the reliability that you need. Okay, so let's just quickly look at an example of data handling. So here I have collected data. My question that I posed before this was, I want to see what is the tendency for male and female, the height tendency for male and female. So I wanted to know, are males usually taller or are females usually taller? That was my question I wanted to know. So yeah, I got 39 participants. And the first one was a male, 1.72 meters, and so forth. I went and I got all my information. But now I have this information, but I actually don't know anything about this information. So firstly, I have to classify my data. So this classification of data can be represented visually as follows. So data has mainly two categories, namely categorical or numerical. So categorical is words, anything that has words in it. Gender, race, which town do you live in? That's usually categorical because it tells you a word, not a value. Then the other one is numerical. So numerical is either discrete or continuous. So discrete means it must be a whole number. So one person, that's your best example as a person. You didn't get a half a person or quarter of a person. And continuous means like liters, you get 7.75532 liters. So it continue. It doesn't stop. You don't get just 1 liter, you get comma and milliliters. So here's just quick 3 examples. Classify each of the following according to the data classification. Gender and race is categorical. Height and weight is numerical continuous because it continues as decimals, and number of people as numerical discrete. So here's my data that I collected. Now I have to sort the data. So in order for me to sort it, I'm going to sort it according to height. So I can either sort it ascending or descending. And in this case, I'm going to start with the smallest number, which is 1.2 meters. And then I'm going to go all the way up to my biggest number, which is 2.15 meters. So yeah, I sorted my data, and already you can see a tendency. Females tend to be shorter and males tend to be taller. After I sorted my data, I now have to organize my data. Okay, so to organize data is to put it in particular order. Category order can be sorted alphabetically, order A to Z or Z to A. Numerical data can be arranged in ascending order or descending order. To organize data, we usually use a frequency table. So here's my data I showed you. So the first one is I'm going to say how many of them is shorter than 1.5 meter. So let's see, I have one male that's shorter than 1.5. Oh, and I have two females that is shorter than 1.5. Then I'm just going to add it into my table. So here I have my categories or my intervals, shorter than 1.5, two females and one male. And I'm going to take this data and I'm going to complete the whole table till the end where it says 24 female and 15 males. After that, I have to calculate the percentage distribution. How do I calculate that? I say, okay, in this interval, there's two females after 24 that's shorter than 1.5. So I'm going to say 2 divided by 24 multiplied by 100 because I want percentage, and that's going to give me a total of 8.3%. I'm going to do that with everything. I'm going to complete it, and already you can see, oh wow, there's 50%. So the females tend to be between 1.6 and 1.69. Males, again, if I want to calculate the percentage distribution, I'm going to say there's one male in this category divided by your total number of males, which is 15. So 1 divided by 15 times 100, because I want percentage, that's going to give you 6.7%. I'm going to complete everything, and oh wow, you can see there's the men. Men tend to be between 1.7 and 1.79. Just remember, guys, these percentages should give you 100%. Otherwise, you made a mistake. Thank you very much.